repeat it. Okay, so 3.6. We're talking about the chain rule. Now this rule is important because every simple derivative problem will probably have this rule in it. Okay, so because this makes it a little more difficult. So the easier ones will have the chain rule in it. So you will get this. You have to. So here's the rule. The derivative of f of u is the derivative of the function itself times the derivative of whatever is inside the function. And I'll show you an example and it'll make more sense. But this is what it looks like. The derivative of the function is going to be the derivative of the function times the derivative of the inside of the function. For example, we have the derivative of 3x squared plus 1 squared. The function itself is something being squared. So we're going to say u is 3x squared plus 1. Okay, so this is the function right here. U is 3x squared plus 1. So the derivative of that, u primed, is 6x. Any questions so far? Yeah?
How come u isn't the square?
Because u is just what's on the inside. Yeah, so now we're really taking the derivative of u squared. That'll make sense, don't worry. So here we have the derivative of u squared, which we just use the power rule for. So it's 2u times the derivative of u, which we know is 6x. Kind of. Alright, and then when you simplify it, when you put u back in, that's what it looks like. Now I'm going to show you how to do it without the u, because I do think that the u makes it a little more confusing. You can do the chain rule without replacing anything. Alright, so let's say that's our function right there. So it's the same problem. We know what our answer is going to be. Our answer is going to be whatever that is down there. So, to take the derivative of this, here's the square. So we're going to do the power rule. So it's 2 times, and then the inside stays the same. But, now you have to take the derivative of the inside. So times 6x. You have to take the derivative of the inside. And then you multiply it. So this becomes 12x times 3x squared plus 1. So we really should be doing that with functions like this too. So if we use the chain rule here, it's going to be 2 times x times the derivative of x. But what's the derivative of x? 1. That's why we never see it. So you take the normal derivative of something times the inside. No? How would you take the derivative of this without the chain rule? Oh, if you were to... Yeah, you could do product. Yeah. So with trig functions, there's no other choice then. So yeah, with this, I guess if you don't want to do the chain rule, you can do product rule. We have this times this, right? Okay, I hope so. Squared means it's the two parentheses. This times the derivative of this, plus this times the derivative of that. Okay, that's the product rule. So you could, but it is more work. It's a little messier. if you use the chain rule, it's a lot more simple. You go from here to there to there.
All this and then
Good job, Alright, any questions? So let me put up, I think this example is going to be too hard for you guys. Okay, let me put up another example first, something a little more simple. Make sure you get that, and then we'll move on to something a little more difficult. So let's say this is our function here. Y is equal to sine of 2x.
I think that's a little bit more complicated.
So to do this, to take the derivative, we take the derivative of the whole thing. So cosine of 2x, so that stays the same, times the derivative of the inside. What's the derivative of the inside? 2. 2. So your answer is 2 cosine of 2x. So that's the chain rule. You take the derivative as if there was nothing on the inside, but then now you do need to take the derivative of the inside.
What if there is no inside?
If there is no inside, then you don't need to do the chain rule.
Oh,
Where the 2 come from?
okay.
The derivative of the inside. So let me do one more. I'll show the in-between step. Okay, so let's say we have that. To take the derivative, it's the derivative of this times the derivative of this on what? Okay, so this becomes negative sine of x squared times the derivative of this, which is 2x. So your answer is negative 2x sine of x squared. So this is kind of the in-between step. Okay, any questions there? Okay, I'll put one up. I want you guys to try this using the chain rule, so don't use the product rule, the quotient rule, or anything other than that. Use the chain rule, and it only should be a couple steps. That's the squared. So 2x plus 5 squared. Go ahead and try that using the chain rule. Yeah. Sure. Alright. Any questions? Alright, anybody want to come up and do it? Go ahead.
Agent super smart. Who gets this right?
Black or green? It doesn't matter. Alright, good. Here you go. Adrian. Catch.
Oh, wow, I gave that to you as a present.
Gave me my own lollipop. Alright, and then so if you distribute it, right, you get 8x plus 20. Any questions there? Yeah, you can leave like this on the test. You can leave like this on the test. It doesn't really matter. These two are the exact same, right? Questions, sir?
Why is there the extra
This 2 is the derivative of the inside. So we did the product rule, and then that stays the same. Times the derivative of the inside is just 2. Alright, any other questions? So that's the chain rule. Chain rule is relatively simple. Now the problem is when there's chain rule within chain rule within chain rule. Yep. Yes, it's just like Inception. Inception. But chain rule. Alright. Any questions? Alright, let's look at a more complicated problem. So an object moves along the x-axis so that its position any time where t is greater than 0 is given by that expression or that equation. Find the velocity of the object as a function of time. Let's go and copy that down first.
You made a mistake.
Where?
It's an object, not objects.
And objects.
Oh.
I object.
Alright, fine.
Yes.
Stupid.
19.
That's why you're not English teacher, right?
I'm thinking multiple things and I'm typing this up. I probably changed it, that's why. Whoa. Alright. So, what expression or what equation is given right now? What kind of equation is it? Displacement. Okay, that's what I was looking for. This is a displacement because it's telling you that the position at any time, the position is displacement. So, how do we find the velocity? Yeah, you take the derivative. You take the derivative. So, let's take the derivative. Okay, so there's our equation. Now, to take the derivative of this, this would give you, what's the derivative of cosine? Negative sine. Good. So it's negative sine of whatever's inside still. So that stays the same. Times the derivative of the inside. And then you simplify that, you get that. That's the chain rule right there.
Chain.
Alright. Any questions with that? Okay, go ahead and try that one. Differentiate, what does that mean again? Find the derivative, good. So find the derivative of sine of x squared plus x.
You do it right.
Motivated by
I don't care, I want a lollipop.
Do it in the
Oh, right.
thingy-majiggy.
Right.
Yeah.
Oh gosh.
It's like a ghetto set. Oh, that's beautiful.
You don't get it?
That's, oh my god.
What? Oh, wait.
He's the best student.
What are you doing?
Don't make
I
me
did
doubt
this
you.
Whatever you think.
Does he have to
Go ahead. See, that's the thing
Do what you did on your page.
Yes, because I did it.
Have confidence in yourself.
Okay.
Don't listen to anything.
Well, that lollipop. Just keep saying that. Well, that lollipop. Or whatever we call that thing.
What did you do?
What are you doing?
Why is this next?
Oh no! No!
Why is there
Oh, we're just kidding!
I thought you were supposed to distribute it.
No!
You don't have to. You don't have to. You can if you want.
What are you doing?
Oh no.
Why is there a T now?
Wait.
P! Why do you have a P in there?
What are you doing?
Write an X.
Okay, good. I have no idea what.
So you get volleyball, right? You get.
Hey, I got it up. Whoa!
Oh.
Yeah, faster reactions and more confidence.
Yeah. You get everything.
You mean distribute it? No, that's fine. You can distribute it.
What is that?
Alright, so I'm going to distribute it real quick. Alright, so this right here, if you had left it like this, you would not have gotten full credit. Why not? No. Nope. That's not why. Nope.
Because
Does
now
not
you're
look
saying
pretty.
cosine of the two things multiplied.
Exactly. I don't know if you're talking about these two multiplied together and then the cosine of that, or the cosine of this times this. Now if you have parentheses like this, then that's okay. Right? It's a subtle difference, but it is a difference. Now, luckily,
About that.
he rewrote it like this.
And it got a lot.
This is obvious. Okay? Now you can distribute it. You don't need to. This is okay. If you want to distribute it, it would be this. 2x cosine x squared plus x times plus cosine x squared plus x. Alright, if you have it like this, that would be distributed. So these two answers are okay. This answer, if you have parentheses here, is also okay. If you don't have parentheses here, that is not okay. Any questions there with the different possible answers? Got it?
Can you give out extra credit instead of
No. Because if you got your normal credit, you wouldn't need extra credit.
I wanted this plus.
Alright. Find the derivative of that. Oh, this is an example. You guys don't need to work on it. I'm going to explain it. I was waiting for you guys to copy it down. Because this is kind of like the inception one. There's a chain rule within a chain rule. So, first thing we're going to do is take the derivative of the tangent part, which is
Secant squared x.
secant squared x. So we're going to do secant squared of 5 minus sine 2t times the derivative of the inside. Now when you do the derivative of the inside, you get, that's 0. So negative cosine of 2t,
Oh my gosh.
but then you got to do the chain rule again to take the derivative inside this function. And that's 2.
Wait, this answer is 0.
No.
Oh my god, it's an inception.
Alright, so
Why is it negative
Wait.
x squared?
Brownie.
Yeah, that's a brown
Is
egg.
that really the right point?
yeah, so it should be positive, right?
Whoa. Round of mine.
Funny.
2 in 1 day.
Buddy?
Funny.
Guys, come on.
How many do we need? 50?
Yep.
Oh my god.
What are we talking about 100 for a cake? I'd rather have the cake.
Yeah, let's
I'll bring something.
Each person gets 1 cake.
I'm not making 30-something cakes.
We're making 100 points.
Fine.
Alright. Okay, so let me explain this again. So we take the derivative of the tangent part, that's this secant squared part of the same thing. Now we take the derivative of the inside. That's just 0 minus cosine of 2t. So that's that. But now we got to take the derivative again of the inside there. And that's the 2. So you're taking the derivative a couple times. Yeah.
So you're taking derivative once. You're taking,
Oh, yeah,
just like that's a brownie.
How come you didn't close parentheses secant square 5 minus 2?
Because it's the trig function of something already. So that's automatically assumed it's one thing. But yes, it's exactly what I said not to do earlier. So yeah, ideally you would have parentheses here, I guess. You want to be...
You see, look, I think
No, I just want to make sure you guys are paying attention.
that's a brownie point.
Alright. Any questions so far? So let me explain the chain rule of this again. So I'll write it down step by step. So let's just say y. Alright. So first thing we do is the derivative of the tangent part, which is secant squared of whatever you're taking the secant or tangent of, times the derivative of the inside. That's just negative sine of cosine 2t. But times the derivative of the inside of this again. That's where this 2 comes from. Yeah.
How far do you usually want to go with this thing?
With the chain rule?
Until you stop?
I mean, yeah, ideally you can go forever. The derivative of that is... No, don't go forever. Just if there's a variable, I guess you can go forever, but...
Well, if you want there, it's like 5 chains.
No. I mean,
2
there could be.
chains.
It could be.
3.
But there isn't. I don't think. Maybe. Alright, any questions as to where in these parts come from first? It's just going to take some practice. Alright, so let's just simplify this now. So the negatives will cancel out, bring the 2 up front, and there's your answer. Oh yeah. Okay, so that should be negative now. Because this one should have been positive. So it's negative. No, it's the same mistake.
Wow.
Now, if this said negative, then I'm going to give you a different value from that, because then it's 2 mistakes. 2 separate mistakes, right? But this answer is based off of this. Unless that's how you guys want me to grade your test.
No, it's okay.
Because if you make a mistake right in the beginning, I'll take points off of that. But if all your answers are correct based on your incorrect answer, I won't take points off of that.
So, did you factor out?
Because the steps are right. Huh? No, I didn't factor anything out. So the negative just I put out front, the 2 I put out front,
Yeah.
and then I wrote cosine and then the secant. Yeah.
Thanks, bathroom. Huh? Bathroom.
Yeah. Alright. Questions with that? What'd you say? Yeah.
You enjoy that lollipop?
Worked for it. Alright, try this one.
Sure ate all.
Better not get it wrong.
You're shaming all of the
Yeah,
people
don't.
in
Hey,
this
am I
positive if you get it wrong.
You don't
Just
deserve
use
a
it.
perfect score.
What?
Use a chain rule, right? Just do that.
Yes. What do you need the lessons about?
I'm not supposed to finish the whole thing.
Just do the derivative part.
Do it right.
Sure.
You better do it right.
Don't be like Ken.
Have confidence.
Dude, right bigger.
Use
the blue. Use the green.
Hurry up!
Yeah, no, hurry up.
Yeah, Kelvin.
God.
You did it right.
You messed up.
You messed up. No, you didn't.
You just rewrote the question.
Wait a second. Because I want to do S or 5.
Yeah, Kelvin, you got it wrong. You don't deserve a perfect score.
This is like a green.
Straight line.
It it's wrong. Can I do it? Just to prove Kevin wrong?
Are you being bitter?
Yes.
Sure.
I mean,
I'm not really sure. I'm not really sure.
I'm glad at least you're not.
You're doing it right, Kevin.
hey, if he does it wrong, can I go up there and like do it right? Because he's
Why didn't you go through the first time then?
That's because he's doing it wrong.
He's being bitter because Calvin got a high
He's not doing
score.
it. I know what you're talking about. He's doing it.
I don't know. I can't see it. I can't see him doing it.
I can tell. He's not even close. No, leave it. Leave it. Alright.
Go for it.
No, I'm not
You got the original equation right.
I don't want to do it.
I didn't do it.
I didn't even know you were
I got 1.4.
Hey. What's your name? Zoom. Hey, Zoom.
You took out it.
Huh?
Gonna be famous now.
Who? Shaq?
Zoom.
Yeah.
Hey. Good.
Wow.
Weird. Right so far.
I didn't write anything. You should have went up there then. Why didn't you? Exactly.
What the heat crackers?
Good call on
I'm a little bit confused about that. Oh, that means it's pointing it.
Oh.
Whoa!
Oh, okay. That's whoa.
What? I like a butt. It's like farting out numbers. That's a weird tattoo. Tattoo on his butt.
Put cable.
What the
Oh,
hell?
I did do it wrong.
I got 45 over 32.
I'm wrong, right?
No, I don't know. I don't know.
Oh, I know what I did wrong.
I know your derivative part is correct.
No, I got a different answer.
It should be right.
Yeah,
The derivative part is right.
Oh,
That was good.
okay. Calm down.
Alright. I don't know if the final answer is right.
Now he got 1.4.
That's right. Here. Dude. No, I don't want it.
Oh,
I just.
You and me. Hey.
I don't want another one. Here you go, sit up.
Can't even look at
So,
that.
if you want to rewrite it like this, then that's completely fine, because it doesn't mean the exact same thing. But, in the book, and everywhere, they're going to write it like this. So you do need to know that this is the same thing as this. Now, if you leave your answer like this, if this were the answer, that's okay. And then if you rewrote your answer like this, that's also okay. So we know what the difference is.
There's a difference.
Okay. There's. Okay, so you do the power rule. So 5 goes out in front, sine of x, and then to the 4th power, because you subtract 1 from that, times the derivative of the inside, which is cosine of x. And then you plug in pi over 3. Sine of pi over 3, that's
0.8 something.
Too much to think about.
is that square root of 3 over 2? No. No, I forgot the unit circle.
Shame on you.
I remember the. Huh?
But it's going to be 5 cosine to 4, right?
No. Because you leave the inside alone.
Oh, the inside.
And then you take the derivative of the inside, and that's this part.
Oh, it's square root 3 over 2.
Yeah, so square root of 3 over 2, that's way 2. Alright, the square root of 3 over 2, and then I guess you can just plug that into your calculator. So to the 4th power times 5, and this is 1/2. And then when you multiply everything, do you get this? Is that the right answer?
Yeah,
Okay,
it's the right
then you get this.
Do we get extra credit? Can I get extra credit?
No, I gave you candy. Alright, any questions there? Alright, but this right here is the important part. And then this is also important. Yeah.
The 4,
Uh-huh.
the power of 4, is that all over the sign or just to the x?
All over time. Yeah. So it should be like this.
I made you nervous, Zoom?
I think that's a yes. Alright, any questions with this?
Oh no. No, it is question.
Everyone got this then? Chain rule's easy?
No.
Yes.
It will be. Because it's going to be the same thing. We're going to practice this a lot. Alright, yeah.
What if some guy, like some test maker, run it, make it crazy
His voice
and
is
evil,
loud.
and he made a sign of
Sign?
parentheses
So just like
and
5
kind
chain
of-
rules in one
yeah,
problem?
Yeah.
Five
What if that
chains.
happens? Could we just like sue the?
Can you just say what?
Could we just sue them?
They'll give you a lollipop if you do it right.
Alright,
They should give an automatic 5.
here's your assignment. Alright, let's see.
homework.
Let me think.
Add a